We will kick it off, Keerti, with our presentation on privacy-preserving machine learning.
Thanks. Hello, everyone. I am Keerti. I am one of the organizers of GDSC Kansas City. And today I'll be talking about privacy-preserving machine learning. And yes, I'll just talk a little bit about myself. I am a PhD student at UMKC. My primary discipline is computer science. But my primary research is more about biometrics and how to preserve privacy and how to protect data, even like it can be before we have processed it or after processing it. So when we talk about privacy preserving machine learning, in the last meetup, we talked about machine learning and how it is helpful for us, what are the methods that are involved in machine learning. Today, we'll be talking about data that goes into machine learning, like training an algorithm or getting a model, and how that data can be at a risk of breaching. And I know a lot of people think like, why is my data so important? Why I have to protect it? Simple reasons we might think that our identities or our privacy is not important, but someone out there might be using either my data or my personal information to create maybe identity theft, create counterfeit profiles, go ahead with insurance frauds, medical frauds, and all of your banking details have your details. So it's really important to protect certain data. Then, yeah, when we talk about what's privacy breach, first thing is we'll talk about breach of information. Any information that somebody has and finds a way to get back to who the respondent of that data is, we call it breach of information. This information can be anything like my name, age, gender, where do I live. My living address is also private information that we consider. And if the respondent is a, call it breach of privacy. What if it's not a person? Like there can be data of cat or dogs. I mean, if they are concerned about privacy, it's fine, but like I'm sure they're not. So, which is why it doesn't have to be belonging to an individual. It can belong to an organization, as we heard from Dexter. So, yeah, if it is about like, for example, we have also talked about face recognition systems. So it uses our face to get access to so many things. Almost everywhere we see biometrics. If there is a breach of this privacy, then people can get access to almost anything they want from us. And when we talk about particularly machine learning algorithms, how can data be at risk? When we talk about machine learning algorithm, it's ultimately a mathematical modeling of a real life problem. So there's always a way to get back to it. And when we talk about neural networks, we know what we are doing, but we are not certain what happens between giving input to a model and getting an output out of it. So neural networks have black box nature. We can control it to some extent, but the rest is not in our control. So this nature is sort of a threat, because if we don't know what's happening with the data, we also cannot figure out a way to protect it. And the second thing is reverse engineering. This is one of the most used methods by attackers. What they try to do is, for example, I have trained my model on a very known data set. And if they know that my model is trained on that data set, they can retrain the model. And based on whatever the output is, they can understand the model parameters. And if they understand model parameters, it's pretty easy to get back the original data. So that's reverse engineering. And then spoofing. This is primarily concerned with biometrics. For example, I have a face recognition system which unlocks a particular based on my face. There can be someone who have made, for example, a clay model or bring in a 3D printed model of me, and the machine unlocks it thinking it's me, but that's not actually me. So spoofing is also one of the, and it was pretty common when fingerprint systems were predominant. It was easier to fingerprints, but I think right now people are doing all sorts of spoofing, including faces. Then how are we going to preserve the privacy in these terms? One is differential privacy. What we do here is we add noise to the input. For example, we talked about spoofing. What if the model was trained on input where I add some like Gaussian noise, or I pixelate them, or I try to change the parameters in my image? Then when the user tries to spoof it, it doesn't find noise, so it's missing that noise. So the chances of it thinking that the spoof data is me are low. For example, I can pixelate the image, I can try to delete some important parameters in an image and retrain the model. This helps the model to train on both data and noise. And then there's private computation. We encrypt the input data. Instead of giving the model my direct face, we use a conversion algorithm to encrypt that data and then give it to the model. So the model is not trained on the actual data, but the encrypted data. So even if reverse engineering happens on this model and they won't get the actual original data that we have, it will be something that's encrypted. Then hashing model output. Instead of encrypting an input data, whatever the output of the model is, we can add an additional layer there using same conversion function and encrypt the output data. So here as well, like if the user doesn't know what the conversion algorithm is, it's pretty hard to do reverse engineering back and there. And now there are higher level of machine learning privacy preserving. These are all like we are playing with the data that we are having. We are trying to change the data, we are trying to add something to the data. But here we'll actually directly work with our models. In distributed learning methods, we have first federated learning. In federated learning, what happens is none. Like even if I am the service provider and I am providing you my model to work with, but I am not seeing the user data. For example, I think this happens a lot with our phones. When we try to text, often like the words that we use come up in the phone as suggestions, whereas this doesn't happen for the other user. So every model, each user, for even if I have like 5 users, my model is distributed to those 5 users. Those 5 models are locally trained on their machines, and then all these parameters are collected back and trained as a supermodel. So neither my main model, if I'm acting as the source, I am not seeing any data that's coming from the user. So if there is no breach of privacy in this case, but one thing is, yeah, it's hard to get the model parameters because an attacker might not know where all the parameters came from and what is the algorithm used behind getting to the final parameters from these subparameters from each user. That's federated learning. And one of the drawbacks of federated learning was also that we are compromising the whole model. So we are giving to the user everything from input to output, everything is given to the user. So, which is why we have something called split learning. This is a bit different, and in a way, it's better than federated learning. So, for our model, we have input and output nodes. We split the model somewhere in the half, and we only give half part of the model to our user or client or whoever it is. So, what they do is they provide us inputs, and wherever the model is split, we have data. This part of data is called smash data, because and this data is not even known to a service provider, but yeah, this data then comes back to a server, and the rest part of the model is stored in the server, and back propagation happens from the server based on the smash data received by the server. So here we are not compromising the whole model parameters, only half of the model is with the user. And because user gives us data to train the model, the input side of the split model is with the user and the output side is with the server to go ahead with the training process. And yeah, these are the primary methods that are used in privacy. And there's also one thing that a lot of people are working on, how we can play with camera parameters in case if we are using a camera-based biometric or camera-based model, how we can make it a lensless camera to be able to not compromise the values. And a lot of research is also going on in computer vision sector. So yeah, these are the reasons why like our data is super important. And an attacker very smart, try to even go ahead and try to reverse engineer your cryptographic parameters, because most hashing functions or most conversion algorithms are widely known and there are ways to learn them, which is why I think trying to protect a model has become super important. And even though if it's a black box, model parameters are not hard to realize. Transfer learning has been very predominant. We have large open source data sets, and most models are usually trained on these, which is why getting model parameters is not hard. So yeah, these are the primary privacy preserving techniques going ahead in machine learning. These are not only for biometrics or user privacy, but these can also be applied to any form of data privacy. That data can come from any industry. It can be some food industry, or it can also be a medical industry where people are collecting data about diseases to go ahead and research with them. Or this can be someone's whole research work that they have done throughout their career and they would want to protect it. These methods can be used for any data that's going into machine learning, and there's always a difference between data and a person's identity. So identity is most important, and that's why we are trying to go ahead and get these models done. So I know this was a pretty short talk, but I know these are super helpful. Any questions on this so far? Anything? Yeah. Was it short? Okay. And yeah, that's what I have to say from my side. Yeah. Anything in the chat? I don't see any.
All right. Thanks, Keerti. So thanks again to Dexter and the T-Mobile Accelerator. We look out for our next meetup. I think it's going to be on either Jetpack Compose for Android or something around Android. So be sure to follow us on the gdg.community.dev to see that happen. And yeah, thanks for coming.
Startup. We're based here in Kansas City, about 10 people. And what we do is we empower professionals to capture actionable insights to their information while on the go. And these are specialists that have to do records keeping, sometimes hundreds of records a day. So think of veterinarians. We started in agriculture, but we also do insurance, construction, things like that. Think of veterinarians, plant scientists, construction inspectors, quality inspectors, and so forth. The part I think is interesting about tonight's presentation is while I grew up on a farm near Kansas City, most of my career was at IBM, and the weird part was I was one of the first people to get a hold of Google Glass when they did their public beta a few years ago. Well, what happened is I thought we were just going to design a little hands-free app for smart glasses 9 years ago. That didn't work too well because the hardware didn't come along, but the privacy-related concerns were massive, no surprise, both consumer level and the business level. And the reason is, quickly, I'll tie it together. Our design point for our service is voice to data. But our design point is the phone stays in the pocket all day. The user never needs you to touch it. They drive their entire system with an interactive device, a little activating button, and a specialized noise canceling microphone. Currently, AirPods are too generic. So what's the point of all this? If you look at public record, as of last year, Alexa collects more information than any other mobile app. So the point is, we think our users tell us this is a revolutionary idea. It's very practical for them and they want it. But because it captures so many things, it absolutely has privacy implications. Business and consumer. Our particular focus is business. So yeah, that's why I want to come tonight and learn more. So That's it.